Tubes. All right. So let's do some homework questions, and then I've got a handout you guys are going to work on, and then we'll see if we feel like doing anything new. Yeah.
No.
So I'm the bigger, more important part of that equation. Yeah.
6.2 number 64.
6.2.
I looked at it.
64. Okay.
Well, it's good to know that you're stuff about it too.
So let's see, 64. Oh, look at me, looking at 6.1.
You looked at it and decided that you
Oh, good. 64 is the parallax problem, right?
Yeah, that one. That one wasn't so bad.
I like it. Let's see. Blah, 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 blah. Blah, 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 blah. So we got this picture here. We've got a star way over there. The Earth at two different, so here's the sun. Earth at two different positions. Star way over there. Let's put it there. Let's make it bigger. Blah, blah, blah. Take the distance from the Earth to the Sun to be 9.3 times 10 to the 7th miles. So, of course, that's here. The angle E1SO. So, E1SO. That angle here is the parallax.
I got 3 of them done.
Alright, I'll let you guys catch up. So how many of you guys have tried this problem yet? Maybe I shouldn't do much with this yet. I know you have, I'm sorry. I'll do a little tiny bit. Let's see. So what are they asking here? Estimate the distance to the star. And they tell me that this angle here is this humongous 0.000 degrees.
Oh, I love what the sign they changed it.
Oh yeah, they do. Blah 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 blah. Okay, so I think I got everything they tell us. So we're right now. I mean, later we're going to expand trigonometry to cover more triangles. But right now, trigonometry that we know only applies to what kind of triangles? Right triangles. So you're always looking for the right triangle in the problem. They kind of gave it to us there, right? And so we're trying to estimate this distance here, this dotted line. So I know this distance here, that's like the radius of, assuming that was a circle, which it ain't, what the hell. We're really far away from it, so it looks like a circle. I don't mean currently, I mean where we're looking now. So what's going to relate what I want to know with what I know?
Trigonomic functions.
One of them. Which one? So I'm trying to help you out. It's not sine.
It's a tangent.
Yeah, because this is the one I want to know. I'm going to call it x because it's like an x-axis. Here's the thing I know, the y. So hopefully you see how to tell which trig function to use in a given problem. If you can find the right triangle in your problem, you can see what side do you want to know, what side do you know, then you know the right trig function to use. Tangent or cotangent, well let's use tangent. Tangent relates those two sides. So what would the equation be that I could write? Tangent of 0.000,211
equals 9.3 times 10 to the 7th
times x.
over
X. My bad.
Exactly. Y over x. So 9.3 times 10 to the 7th over x.
You just got to really plug it in your calculator, right? That's a big one there.
Be really careful about the fact that this is degrees. Always put the degree symbol on there if you mean degrees. The minute it does not have a degree symbol, it has got to be assumed to be radians.
Yep.
The only thing that differentiates really, I don't always have to write rad, but it's nice to do that. If you don't see a degree symbol, you know it's radians, or else the person that gave it to you made a mistake. And it's too bad for them. You've got to assume it's radians. How we doing there? Is that cool? Okay. That was a nice little,
It also
that is
helps if
cool
you-
sound.
Also
Huh?
helps if you put it in the scientific notation form on your calculator too.
Okay.
Sorry.
That's right. All right, cool. Anything, that should be, actually, I mean, I did a lot more than I wanted to, but all, that pretty much solves it. You just got to do the algebra for this. All right. But it's all about finding your triangle, figuring out what sides you know. Yeah.
DD number 54.
Oh, good. I like it. All right, so 54 in the same section, I-62. Blah, 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 blah. Determining a distance. A woman standing on a hill sees a flagpole that she knows is 60 foot tall. I love that.
She just needs to
Yeah, she does. She's got this weird psychic ability, very specific. The angle of, all right, so good. So this is introducing some semi-new terminology. Hope to God you guys are capable of, if you hit something you don't know, look it up in the index or try to find it in the section. I love it when students turn homework in and they say, I didn't know what this meant. You got Google nowadays, or just ask me, right? Don't turn in homework saying, I don't know what this meant. Yeah. It's good symbol. So one standing out sees a flagpole she knows is 60 feet tall. So this sucker is 60 foot tall. Angle of depression. So they're always measured relative to horizontal. So the angle of elevation, if I see a plane up there, the angle of elevation is the angle that I got to turn my head through to look at it. If I'm standing in the Grand Canyon and a friend of mine is going down the side, hiking down the side, the angle of depression would be, if I want to see them, that's the angle I got to move my head through away from the horizontal. You guys with me? Mm-hmm. So in a plane, you talk about angle of depression very often. On the ground, you talk about angle of elevation, because there's not much to see if you look down. Ground. You can still do that. But so her angle, so here's the straight horizontal to the flagpole. Here's this to the top, make you a little taller. And they tell me that's 18. And here's this to the bottom, and they tell me that's 14. Coolness, man. So the one last thing I'll tell you, I haven't really told you much, this is actually what they give you already. But the thing that ties all this together is how many right triangles have to work with up there? 2. And for each one, I know this thing is 60 foot tall, so I have no idea, each one of these separately. So we're trying to figure out what this is, right? Mm-hmm. That distance. So what do I know about this, for example, and this?
They equal 60.
Together they equal
Together they equal 60. So if this one is
D.
Y, what would this one be?
60 minus
60 minus 1. So you have 2 triangles to work with. You can get 2 equations, which very often means you must be dealing with 2 unknowns, and that's a system of equations. Right? So let's do 1 equation, then I'll let you guys try the rest of the problem out on your own. What's 1 equation? That top triangle, the top right triangle, what can I write? What trig function relates what I want to know with what I know? Again, it's tangent. Tangent happens a lot, because very often we want to care about the hypotenuse. Sometimes, of course, we do, but very often we don't. We care about how far we are from something and how tall it is or something like that. So we get tangent a lot. So if I say tangent of 18, that must equal over x. Cool. Now just write your other triangle, and then together you should be able to figure out. And just to help you out, one more thing. What letter do you care about?
X.
X. Which means, once you get your 2 equations, which letter do you want to kind of like kill?
Y.
There you go. Okay, good. You're on the right track. People solve for y, and we didn't care about y. Yeah.
Dang it. Look at it. I lost it. Oh, yeah. Oh.
You can't have
Got it.
gotten
It's coming.
far.
All right, there it is. 6, I'll just give you the minus sine pi over 4.
Wait. 6 minus what?
No. I got to evaluate this expression without using a calculator.
Okay, so
And it's sine, well, in parentheses, all in parentheses. Sine pi over 4 times cosine pi over 6 minus sine pi over 6
Okay.
times cosine pi over 4,
Yeah.
parentheses all squared.
Okay, all right.
So,
So what's sine pi over 4? You know what that is.
it's
Rad 2
Rad
over 2.
That's right, 2 over 2. What's cosine of pi over 6?
So rad 3 over 2.
Yeah. Minus sine pi over 6 must be the 1/2. Cosine pi over 4 is the 2 over 2. And then just simplify that.
I think I was messing that up.
Well, don't. So these already have like denominators, right? That's kind of
Yeah.
nice. So here I get, on the top,
Rad 6.
rad 6 over 4 minus rad 2 over 4. So I get rad 6 minus rad 2 over 4. Please, dear God, don't make that rad 4. You can't put those together because they're not like terms. Good. Squared. So I'll do the bottom, that's 16.
Yeah.
On the top, you just FOIL the bad, do that.
Okay.
Right, the big mistake I see is people make that 6 minus 2 over 4. So it's 1, yeah. You square this means you got to write that twice. You got to FOIL it out. Squares don't distribute across minuses because they don't play well together. Squares are based on multiplication, not subtraction. Okay, cool. Yeah.
Oh, when I started the homework assignment, I was trying to do it. Did
This
you
one?
came first? Oh no,
Chris, you got a question about this one?
No, well, it was kind of, it's related to it, yeah. What if they were rad 2 minus rad 2?
Well, then,
Cancel each other out?
yeah, exactly. Yeah, yeah.
I was trying to do it the way you taught us about x over y is that would be cosine and vice versa.
Yeah.
And it didn't work. Like I was trying
I
to.
like the way you said it. Just trying to do it the way you. So which one are you talking about?
Let's just go with 3. I mean,
3 and where?
6.2. I mean, I get the right answer, but I don't know why your way didn't work.
Oh, so what's the big thing about my way?
No idea.
For the highway.
The angle has got to be in the base. I kept making jokes about you can twist your head, you just got to turn the triangle around. So when they give me a triangle like this, and they give me, so I got 3, 4, 5, here's my right. Here's the angle that I'm talking about. I have to turn this thing around. So this will be the y side. The angle's got to be in the base, so that it will have come from the unit circle. Angles are always going to be in the base. Yeah. That's the one advantage SOHCAHTOA has. Right, versus the 80 billion that the other way. But, yeah.
I got it there.
Good. And I really want you guys to understand, I appreciate it. I didn't make this way up. This is the way it's done. SOHCAHTOA was people's attempt to bring a mnemonic device to help students out. But the people that created it didn't think, oh, it's not going to get them further. You know, people don't stop and think, foil, you don't need foil. You don't need it. People thought, yeah, let's make it interesting. We're going to make aluminum foil jokes and all kind of shit. But then students freak the hell out when you put one more term in there. And I'll blame them. They're like, my foil doesn't work. So you didn't have to teach them foil in the first place. So, again, I'm not, of course, I put everything in the wrong place, but, right? Yeah. I'm not shitting on your SOHCAHTOA if you like it. There's nothing wrong with it, as long as you realize that you can't, it's not going to help you forever. You have to also understand the other way of looking at things. Sine likes y, cos likes x, as long as the angle's in the base. That makes other things we do later make so much more sense. If you think about it like that, physics will make so much more sense in case you have to take physics. If you don't, then okay. Yeah.
And you said on 54, so you're going to do the tangent 14 one, and then you basically
Yeah,
put them
one.
equal to each other too?
Well, you got to solve for a variable, right? I would recommend doing substitution on that kind of problem. So I'd solve one of them for y, because that's the one you don't care about.
Okay.
Yep. Chris.
Would you do 5.2, like number 50? Help me out.
6 point?
Give me a, no, 5.2.
Number
Like number 50.
50?
Give me a hint. Something or something. Maybe it's too easy and I'm just getting retarded about it.
Oh, okay. No, you're fine. It's kind of funny. Somebody remind me, what's secant of t defined to be? 1 over cosine. So what's interesting about cosine t times secant t? It's 1. So then that's why they can say, what's the sign of this in any quadrant? Well, when cosine's negative, secant is going to be negative, because secant is 1 over cosine. They're both negative at the same time. They're both positive at the same time. So if that's negative, that's also negative. That's positive, that's also positive. So it's always going to come out to be positive 1. So what's the sign of this in any quadrant? Positive. Done. So it's just rewriting this in terms of, the basic 3. And then you realize, oh yeah, it just goes down to 1. It's positive everywhere. Cool. Yeah.
Do you remember sending me your position?
Oh yeah. All right. Sorry. Just the name of the problem is interesting. It sounds like a really weird pub in England or something. The Tethered Cow. So we've got basically this shape here, right? We got this poor little cow dude.
It's a good cow.
So it's a cow.
Kind of like a pig.
100-foot rope. That is my generic mammal, 4-legged mammal. L-shaped building, blah, 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 and they give you all these things. So I want you to realize, you can see where that cow's been grazing, right? And you can see basically what the shape is. So for example, this here, that is, and of course the picture in the book is much better than mine, but what is that? What shape is that?
Right circle.
It's part of a circle. How much of a circle is it? A quarter of a circle. Let me just stop right there. You guys see that? To find the area of that, then, I need to know its... Find the area of a circle, you just have to know its radius. Right? So, of course, the radius for this main area is 100. Yeah. So you find the area of the circle with a radius of 100 feet, and you take 1/4 of it. Right? Now, notice the minute that cow walks here, so if the cow is now here, then when it tries to go further, what's its new radius going to be? So this is 60 here.
40 is going to be 40.
It's going to be 40 feet radius now, right? So now the circle it makes here is going to have a radius of 40 feet. So anytime it hits a corner, it's going to make a new smaller circle because its rope is going to get caught there, right? It's not going to have as much freedom to move around. Here, oh crap, it can only do this now. That's awesome, the arm does that. Didn't really think about it before I did that. So I can go, yay, and then I got to go, shit. Okay? The really yummy grass is right there. You jackass, give me a little longer rope. You guys understand how to look at that problem? I expect questions on the problem. When you first look at it, like, yeah, we've been told enough to do this, sure. But it's just a realization that you're doing circle areas. You just have to know the radius of each circle. And why would the radius change? Because it's going to get caught on a corner if it tries to go that far. That's why the shape changes. Looks like a shell or something. So you got to do the same thing back here. When it gets caught on that corner, how big will the radius be there? So forth. All right, I'll let you guys try it. Still zero reaction. All right, so anything else from homework?
55. 2.
Steinberg's, you're right.
Yeah, I'm struggling today.
Sorry. So let's see, blah, blah, blah. Oh, good, okay. So in 5.2, we learned something that we haven't quite learned yet, so you're right. There was one last thing I haven't talked about. I was saving it for today. But, it's a simple process of going back and looking at an example. So I'm going to build up what you need for this problem. And example 5 is exactly like that one. Example 6 actually is even more like that one. Example 6 is exactly like that one. So let me get what's sine squared of theta? I mean, that's it. I'm sorry. What's sine of theta? Think of that. What's that defined to be? Basic definition.
It's the opposite over the hypotenuse. Opposite.
You think I want SOHCAHTOA? Yeah. Y over R. Sorry, Chris. I never want SOHCAHTOA. You can use it. I don't want. Cosine theta. What's the definition? X over R. And of course, what's true about X, Y, and R? Where do they all come from? Unit circle. How are they related? What's the basic definition amongst them?
Y squared.
Yeah.
X squared equals 1.
I like all of them. I don't know what you said they're in. Okay. Right? Now, one little convention. I don't like to waste time. I already wrote it up there, but oh well. We don't write sine theta squared like this. We actually write it like that. So that's understood to be sine times sine. Sine theta times sine theta. You with me?
Yes.
Okay. One other little thing. If I had now in our future, but I want to talk about it right now. In our future, we would have to solve equations like this, or the sine theta. We could do this right now. We could solve that equation, sort of, right? You just got to figure out when is sine equal to rad 3 over 2. But you don't solve this equation by dividing by sine.
Mm-hmm.
Why does it make no sense?
Because they don't cancel.
Just like our earlier discussion about not even that. It's not even that. It's much more basic than that. If I wanted to solve log x equals 11, do I divide by log?
No.
I apply the inverse function of log, right? This is a function. If I have f of x equals 11, I don't solve for x by dividing by f. That doesn't make a damn bit of sense. So sine with nothing after it makes no sense. Zero. Really want that understood right now, because I have my Calc 2 students doing stuff like this, tears streaming out my face. Because at that point, that should almost be physically painful to write. So, all that's aside. What would sine squared theta be then? Sine theta is y over r, so sine squared theta would be y squared over r squared. What's cosine squared theta?
X squared and R squared.
So sine squared plus cosine squared would equal x squared plus y squared over r squared. Is that cool? And of course, what's x squared plus y squared? What's x squared plus y squared?
R squared.
R squared. That's the most fundamental identity. We're going to learn so many trig identities. I will tell you exactly which ones you have to memorize and which one you don't. I have a nice big handout. It's all in green. For some reason, I stole it from somewhere. So here's the most fundamental, the number one most fundamental trig identity. Sine squared plus cosine squared equals 1. Now take a second. Take that expression, divide both sides by cosine squared. Just because. I'm saying it again. Take a minute. Take that expression, divide both sides by cosine squared. See what you get. So you know how to divide both sides of an equation. Like everybody's, a lot of you guys are still just staring at me. So take a second, take this expression, divide everything by cosine squared. So what do you get here? You get over cosine squared, over cosine squared. Am I allowed to do that?
Mm-hmm.
Yes, except for where theta makes cosine 0, right? But that's kind of inherent in the equation I'm going to get. I can't use it where it's undefined. It's fine.
Mm-hmm.
So what do you think sine squared over cosine squared has got to be? Tangent squared. Is that cool? Because tangent, sine over cosine. Squared is tangent squared. Cosine squared divided by cosine squared is 1. And what's 1 over cosine?
Is this sector?
It's not sex, sorry. Oh, it's not sex. Let me just divide one by cosine. Secant squared, yeah. I like that. Yes, that's the only way that nerds get sex. It's mispronouncing secant. Now, what else? So that's the second one. So that's the most fundamental one. You got to know this one. There's the second one. You got to memorize that one too, right? But I really, at this point, I've used it so damn much it's in my head. But when I first learned this, I didn't memorize the damn thing. I just knew how to get it real quick. So I only had to memorize one stupid little thing to begin with. Right? What else could I do to that equation? Maybe get a third identity.
Divide by sine.
Divide by sine squared, right? So if I divide by sine squared, I get sine squared over cosine squared plus cosine squared over sine squared. Is 1 over, no, Jeff, you're divided by sine squared.
Sine.
There's a little convention that we use sometimes, use S for sine theta.
1 plus cotangent.
This will be 1 plus, what's cosine over sine? Yeah, cotangent squared equals
Cosecant.
cosecant.
Yeah.
Bam. So if I wanted to know, if somebody gave me cosine, let's do one of your problems there, Chris. Somebody told me, what did they ask you exactly? 55. If I'm in quadrant 2, I want to write sine in terms of cosine. So I'm in quadrant 2, I want to write sine in terms of cosine. So I want sine t equals some mess to do with cosine. You with me? So I want sine as a function of cosine. So where do you think I start? What relates sine and cosine?
Tangent.
No. Which identity?
The first one.
Yeah. Start with this. Because this is something I can actually solve, right? This is an equation. This is an equation I can solve for sine. So solve that for sine. How do you solve that for sine?
Minus cosine.
Yeah, you subtract cosine squared, and then you
The square root.
take a square root. Of course, when I do that, I do plus or minus, but which quadrant am I in?
2. So it's
I'm in the second quadrant, right? So what's sine in the second quadrant?
negative. No,
Negative,
positive.
it's positive.
Good, because I'm still up here. The y's are positive up here. You see how SOHCAHTOA would help you out, Chef?
Yeah.
You use sine, goes like y. I know exactly where sine is positive. So that means that sine theta, which one do I pick?
Positive.
Positive. There you go. Sweet. So if they would have said third quadrant, it would have been the same exact work, except I would have just picked
Negative.
the negative.
And that's because sine and cosine, if they're positive together.
No,
Never mind.
definitely. Sine's like y. So sine is positive in the first and second quadrant.
And
Cosine's positive in the first and fourth. That's where x is positive, right? Cool, okay. Alright, so anything else from homework? Alright, so here's what I want you guys to do. You can work together or alone. You're not going to turn these in. We're going to do these together, but you probably